Physics, a paper 1 out of 70. So how much can you get through in 30 minutes? First of all, I'm going to just like check through it. So particles, I can do that. Electricity, I can't do that. Force of gravity, maybe. Waves, I might be able to get my way through that. Density, okay, yeah, there's no way, so just gonna see how quick. So 30 minutes, starting at 1 minute to 1:31. Yeah, and then we mark it and see. So I've done something like this before, but not this one. So a minute starting now. Particle X, UUD neutron. Type of interaction, weak nuclear. And today the class of particle bosons, is it gauge bosons? Okay, show clearly how charge and baryon number are conserved. So this is a UDD is decaying into UUD plus a electron plus a antineutrino. So charge equals 1 equals, oh nope, 0 equals 1 minus 1 equals 0, therefore conserved. And baryon equals 1 equals 1, therefore conserved. To all the particles, including the quarks. So for this one, there's 2/3 minus 2/3 equals 0, and 2/3 plus 2/3 minus 1/3 minus 1 equals 0. Done. And baryon, 1/3 plus 1/3 plus 1/3 equals 1/3 plus 1/3 plus 1/3. I don't have time for this. Name the unstable proton. A muon is an unstable particle. Take the name of particles that produce electron. Done. Filament lamps, blah blah blah. Same term of electron motion. Filament lamp is a curve. Why is it a curve? Why is it a curve? This would be due to the fact that there would overall be an increase in the temperature. Due to this, there would be more collisions, so more charge, until there is not as much left, so it would plateau. That is why it would not be proportional. I have to actually rush, that's why the handwriting is a bit madness. Determine the resistance on the resistor. So the resistor, this part, so that is 8, and that is, okay, let's just say that's 8. V equals IR, V, and 0.58 is 8 over 0.58 is approximately 14. Okay, the resistor and the filament lamp are connected in series with a supply of variables, blah blah blah. Determine the EMF produced. So what is the formula for EMF? I don't think I have time for these. It's 3 marks. Do I have time for this? No. The resistor and filament lamp are now connected in parallel. Determine the resistance and the parallel combination. EMF, don't know what EMF actually is. Like the resistor and filament lamp and working temperatures that many ohms, filament lamp has length without a diameter of that. Calculate the resistivity of the metal we use. What? How? Oh, I really should learn this. But at least I get a mark for writing ohms. I hope. I hope there's a mark for writing ohms. Why is there so much electricity? An electrical wheelchair powered by a battery allows the user to move around independently. One type of electrical wheelchair has a mass of that much. Maximum distance and travel on the ground is that many kilometers. You use a mass of that, and a maximum speed of that. A battery uses as well. And can that So the average power output is about 100 watt. One type of electric wheelchair has a mass of that much. Maximum distance and travel on ground level is that many kilometers. And reaches maximum speed of that battery you're using. Don't know what okay, screw this. I don't know what EMF is. Calculate the force of gravity exerted on a wheelchair parallel to the slope. Well, it's downwards is 9.81. It's an angle of 45 degrees. So, what? Calculate the force that gravity exerts on the wheelchair as use a parallel to the slope. What slope is this? So it's asking for this part. So then what? So is that 90 over sine 80? But that's 4.5. That means that this angle is 90 plus 4.5. 180 minus answer is a 5.5. I would also want to clear up that I have just started at A-level, so that is probably why I can only do some of this. So is that 4.5 over sine 90 times sine a 5.5, 4.4, so 4.48612. Force equals answer times 9.81 times 2. Just go at 88. Rough mark anyway. Calculate the maximum speed of the wheelchair is the user travelling up the hill with a power output of that much. Assume that resistive force due to friction is the same as 3.2. What? So total resistivity is, what is it? Explain how the maximum weight of the wheelchair is affected by the mass of the user and the speed of the wheelchair. Effects of mass. This would affect how hard it would go on the ground. Friction. So due to this, the less mass equals the less amount of friction, so more speed / more kinetic energy. The faster it goes, the quicker it would go, so would mean there would be more air resistance, but would also, while the maximum range increase or reduce it range because you're just going quicker. Come. Double split. Oh, we're doing this in a week or so. Explain why a single strand falls to a minimum between B and C between what? Explain why a single strand falls to a minimum between B and C and between C and D. Okay then. Minimum, that means that phase difference. They have a phase difference of n plus a half wavelength, so would be out of phase, would cause destructive interference, so would fall in strength. So determine the frequency of the microwaves that are transmitted. So frequency is wave speed equals frequency times wavelength. Okay then. So the distance between the slits of that and that. Oh, we're not using that equation, are we? We're using the other equation. What are we? Wave speed equals wavelength times frequency. So what's the waves? Okay, so two slits, blah blah blah. So we're working out the frequency, and we know the wave speed. But the wave speed is 3 times 10 to the 8. I'm pretty sure. 3 times 10 to the 8 is wave speed. And the wavelength is distance between 2 slits, and the microwave receiver is that. And that, why does it tell you how long it takes? A signal is then detected. 2 slits. Is there a difference in time? Okay, distance, position D is that, and it's that many meters. So the path difference, 0.723 minus 0.667, is 0.56. So it's the difference to reach the same point. Well, they're not exactly reaching the same point, but it's the same. Oh no, they are, because they're going this way and this way. A path difference is that. So it's a wavelength of half a path difference, isn't it? Answer divided by 2, 0.028. And we've got the wave speed, so that is 3 times 10 to the 8 over answer. 1.07 times 10 to the 10. Come. The intensity of the wave pattern is the same. Explain why the minimum intensity between B and C is not 0. Wait, between B and C is not 0. Well, that is because, as we know, C and D would conduct destructive interference. Therefore, we know between them there can not be a full cancellation, so we know it cannot be 0. Vertical aerial position at B is rotated slowly through 90 degrees until it lies along AB. Then explain the effect of a signal while it rotates. It would be polarized, so would reach a maximum, then 90 degrees out would reach a minimum, then up to 180 at max, and then 270 at min. So the signal would become 0, then get better, then worse. Come. What's next? Figure 6 shows a structure that supports a horizontal copper aerial wire W used for transmitting radio signals. The copper aerial wire 12 meters long and its area cross-sectional that Young's module that many pascals. So the extension produced in 12. How much of this do I have left? Oh my god. Oh no. Copper aerial wire long model that many pascals. So the extension produced is a 12 meter length of an aerial when the tension is that much less than 4 millimeters. The hell? Okay then. So I'm actually going to look at the thingy-majiggy, and I'm going to look at Control F extension. There's no extension formula. EXT. There's no extension formula. Show that the extension produced is 12 meters. Okay, surely tension. Wait, does it actually not have a formula for? I swear, like, extension equals a half. What's the formula for extension? Oh, that's extension of a spring. Half. What the hell? Show that the extension produced is a 12 meter length on aerial wire when the tension is that much less than 4 millimeters. Well, that's 12 meters. And the average cross section is that. Okay. Okay, so what I'm going to do is I'm going to look in the equation sheet, do the smart. Actually, I should really focus on the big marks. When wind blows, stationary waves can be formed on the aerial wire. Explain how stationary wave is produced and why only where a specific frequency can form on the aerial wire. Okay then. Stationary waves produced by a reflection. So two waves at opposites would cause superposition, and at nodes would have destructive interference, and at antinodes would have constructive interference. The waves would have to be coherent and monochromatic, and only specific frequencies can be made, as you can only have specific frequencies of waves on the stationary waves. Okay then. Calculate the mass. So density equals mass over volume. So we're looking for the mass in kilograms. Calculate the mass of 1 meter length of the aerial wire. Okay then. Density equals mass over volume. Density equals mass over volume. Meters, kilograms. So density equals mass over volume. So that is that. So 18000 times length of the aerial wire. So 1 meter length, mass times volume. The copper wire, 12 meter long wire is a cross section of that much. So the area is that much times 1.6 times 10 to the minus 5, and that's 1 meter of that. So that is 0.1424. Nope, wrong place. Yay. 0.1424. Calculate the frequency of the wave when the third harmonic is formed on the aerial wire. The third harmonic is the one which looks like. Okay, draw the thing out. Let's look like that. I think I might redo this again at the end of the year just to see. So this is 12 meters. What do we have? 12 meters. What's the tension on it? Young's modulus. I don't know what Young's modulus is, so I actually can't do it. That's the problem. Like, I actually cannot do it. Sketch the standing wave when the third harmonic is formed. Okay. Okay, I see how it is. So it'd be like that, and it'll be like a terrible drawing, but it will get me the marks. High winds produce large amplitudes of vibration in aerial wave. Explain what a wave may sag when the high winds stop. Well, why does something, because it's deformed, may be deformed, and due to that cannot return to the original, therefore would be stopped. Oh, multiple choice. Which statement suggests that electrons have wave properties? Nope. Nope. Yes. Nope. Yes. Okay. In discharge tubes, a high potential difference applied to hydrogen gas contained in a tube. This causes the hydrogen gas to emit light that can be used to produce visible light spectrum shown. Visible light spectrum has been used to predict some of the electron energy levels in a hydrogen atom. The energy levels predicted from the visible light spectrum are those 0 and that many electron volts. Some predicted are shown here. Calculate the energy in electron volts of the photon of light that's the lowest frequency. So energy equals Planck's constant times frequency. Wait, what? Okay, so we got the wavelength. What do you mean? So calculate the energy in electron volts. Some predicted. So the wavelength is this one. So this is the lowest frequency, but has the highest wavelength, so lowest frequency. So it's that 6.56 times something over the wavelength. And what is the wavelength? The wavelength is the wavelength is that. So that is 656 nanometers. So we need that in meters, so 656 times 10 to the minus 9 over 6.63 times 10 to the minus 34 times, and then hydrogen gas. So is that the, what would that be? Would that be speed of light, I'm hoping? Times 10 to the minus 34 times 3 times 10 to the 8 over times 10 to the minus 19. So that is 3.03201219.5 times 10 to the minus 9. And then we need to convert that into electron volts, which would be 1.9. Identify the state of an electron. Wait, what? Identify the state of an electron in an energy level labeled 0. Delocalized. Which means they're free, basically. Identify the state when absorbed is minus that much. So, minus that much. So, lowest possibility. Explain why the energy levels are negative. Why are they negative? Is it because theoretically photoelectric effect? Why are the energy levels negative? What happens? So basically energy is given to a plate, and then if it reaches the threshold frequency, electrons start buzzing off. So well, energy is given and it's yeeted. So to be free, energy must be given. That's the best thing I have. Discuss how discharge tubes are made to emit electromagnetic radiation of certain frequencies. What do you mean as in? Discuss how discharge tube is made to emit electromagnetic radiation of specific frequencies. Explain how there's a high potential difference across the tube. Discuss how energy level diagram predict the spectrum shown in figure 8, and show how one wavelength of light is related. Is this it? Yeah. So I honestly don't have a clue. So a certain frequency must be reached to allow the electrons to be emitted. 1 EV equals 1 PD, therefore there will always be a high PD across the tube. Explain how predict the spectrum shown. The prediction can be given by the formula energy equals h speed over lambda, and this would allow for the predictions would therefore allow for the electrons to be emitted as a photon, therefore would mean that the emission of electromagnetic radiation of specific frequencies would be allowed in the photoelectric effect. Frequency is not always constant. It can be different based on different things. This is just me brushing. My handwriting is doing a bit of a madness here, but we move. Okay then. Table blah 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 65 to the horizontal. Calculate the tension. Or 17. Calm. We might as well put in an answer for all of them. It's less than 4 millimeters. Might as well just use the numbers. So 5 times 4 divided by 12. 5 times 10 to the 2 times 4 divided by 12. Calm. So that one is, we have to like put in stuff now. Quick. What else did I not answer? Maximum speed. Wait, it just looks disabled anyway. Disabled. Actually, no, we're actually putting in a real speed. So he's going up, he's going flipping now. So that means that we could assume 20 meters a second. He is in a wheelchair, so let's say practically 6.5. 5 might be a good bet. Show the average power output during what is about 65. So this is basically countdown minus 12 divided by 1.5. Oh, cool. So 55 plus 65 minus 12 divided by 15 plus 12 equals 100 watts. Perfect. During the journey due to friction, assume that the energy level, calculate mean resistivity force. 7. We have to. Resistivity 14. 12. 7. Are there any like long written answers that just haven't? Okay. So I think that's the best I can do, to be honest. So we need a mark scheme. So physics and maths tutor. Get that up. Past papers, paper 1, 2017. Neutron weak bosons. Neutron weak bosons. Well done. These are like the max I'm gonna get. So charge, yes and yes. So proton and electron. Nope. I should be doing this in green as well, but electron plus antineutrino plus a muon neutrino. Oh, who would have thought it, yeah? Okay then, why IV characteristics? So, the increase in current leads to an increase in temperature. This causes movement. Yep. Therefore, rate of collision. Nope, I did not like that. Why would I not like that if I wrote the other three? But I was like, nah. Okay, allowing the range of 14 to 15. I actually did get 14. Well in. The answer is 0.8. So no, not at all. Next one. Nope. I guess these ones. Next one. Yeah, no. But I did get a mark for writing the ohm. So haha. Beesh. Next one. 3.1. 108. Wait a second, wait. No, but wait. Well, theoretically, give us a second here. They did do a thing. Did I do the same thing? No. Not at all. Yeah, no. There was a chance there. Okay, next one. The answer was 73. I got 7. Nah. Next one. 92. 88. 0.61. Yeah, nah. Okay then. Reduce the range. What effect? Yeah. And more energy, power, more acceleration, more kinetic energy. Yep. And the reduce the range and it would go quicker. Yes. More resistance. Well in. So path difference for the two waves. Yep. And destructive interference. Well in. So this says 10.7 times 10 to the 9. So 1.07 times 10 to the 10. Which is the same thing. So 4.3. Intensity decreases with distance. Nope, I wrote destructive interference, which is, wait, 3i. Amplitude and intensity do not cancel out. I did write that. Where did I write that? As we know, conclude, blah, 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 fact, we know that it cannot be 0, so they don't cancel out. Well in me. 4.4, signal decreases or becomes 0. Magnitude would become 90 and then would become 0. Yeah, it's literally polarized. And then would flip through the thing, so it would do the grafting. So it would do the ya. So it would be the disabled W. Yeah, yeah, we don't talk about this. It was 3.1. I actually got half. No, I didn't get half the answer. 12K, nope. Okay, stationary waves. Yep. Travel in opposite directions. They superposition. Well, they superpose. And certain frequency have to be nodes. Yep. Well done, you can do the stuff that you've been learning. Okay, next one. 0.142. 0.12. Yep. Oh, I didn't guess an answer for this one. Oh, never mind. And diagram shows things. Yep. Okay, copper may be stretched. Permanent deformation does not return to original length. Deformed. Yep. So the third box. 1.9. 1.9. Well in, I can do maths. They're just 3. Delocalized means 3. The lowest level an electron can occupy. Lowest possibility. Yep. And why is it negative? To become free, to remove an electron, energy has to be supplied. Energy must be given. Yep. Oh, this is a madness, yeah. Okay then. PD accelerates electron. Well, I already haven't got 2 of them because I just haven't done C. But PDs accelerate electrons, produce high speeds. That's high. Electrons, I did that one. Electrons have to have sufficient energy to excite / release them to higher levels. Yes. I think those are the only ones that actually got. Photon, different energies, and the formula. I did write the formula, so that's 3. So if we were to count this, that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 9, 20, 21, 20, 23, 24, 26, 29, 30, 31, 30, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44. Well, yeah, Jesus. So I dropped 26. This is not great. So AS Physics grade boundaries. Okay, AS Physics grade boundaries. So Control F and then Physics. Okay, so out of 70, and A was 92 divided by 2, 46. Yeah, but I am going to assume that this was bare nice marking. So we are actually going to go through again. So this one, we could theoretically change that to a 2. This was right. This was right. This was, we don't talk about this. This, but I think it was a perfect mark answer. But I think you could negotiate a 3 marks on this. So overall, I think an A or a B